So for number one is draw the direction field of y prime equals 2y over x. So we'll just start off with finding the slopes at each point. So for point 1 is going to be 2 over 1. This one's going to be 2 over 2, 2 over 3, and 2 over 4. And then to use this to draw the direction field, okay. And then the final direction field is going to look a little something like this. And that's what number one is going to look like. So for number two, it's going to be to solve 2y prime equals x for y with separation of variables. So to start off, going to equal 2 dy over dx equals x times 4y. And then we were going to switch the y and the dx. So it's going to equal to outside of the integral dy over y equals 4, move to the outside of the integral to x dx, which is going to equal 2 times ln of y equals 4 times 1/2 x squared, and then plus c. So ln of y is equal to 2x squared plus c, and then we're going to move that 2 under here, so divided by 2. And then ln of y is going to equal x squared plus c over 2. And then, so we combined these two. This is going to be our k. So e to the ln of y is equal to e x squared plus k. And then the final answer will be k e to the x squared. Okay, so number 3 is going to be approximate the integral of 2 to 5 x cubed dx with the midpoint rule and with the 3 intervals. So from our f of x is going to be x cubed, our a is going to equal 2, b equals 5, and our n is equal to 3 for the 3 intervals. And then the basic formula that we're using is a to b f of x dx f x0 plus x1 over 2 plus f x1 plus x2 over 2, and so on. This goes on until f of x of n plus 1 plus x of n all over 2. So our x is going to equal b minus a over n, which for ours is f minus 2 over 3, which just equals 1. And this is going to be the length of our subinterval. So for f of 2 plus 3 over 2 equals f of 5 over 2, which then equals 125 over 8, which results in 15.62. And then for the other ones, which are simpler ways, is f of 7 over 2 equals 343 over 8, which equals 42.87. For the third, f of 9 over 2 equals 729 over 8 equals 91.12. Okay, now we're just going to sum all these up together and multiply it by 1. It's going to be 1 times 15.62 plus 42.87 plus 91.12, which equals 149.62. Okay, and for the last one is going to be to solve the integral of cosine squared x sine cubed x dx using substitution. So for our substitution, our u is going to equal cosine x. Our du over dx is going to equal negative sine x. Our dx is going to equal negative 1 over sine x du. Okay, just to plug these in, it's going to be u squared times u squared minus 1 du. And then just to simplify it a little bit, it's going to be u to the 4th minus u squared du. Okay, and now we're just going to be separating these. The integral of u to the 4th minus the integral of u squared du, which is going to equal u to the 5th over 5 minus u to the 3rd over 3. And then we're just going to be plugging back in our u, which was seen over here, cosine x, which is going to equal cosine to the 5th x over 5 minus cosine to the 3rd x over 3 plus c, and simplified down, that's going to be 3 cosine x minus 5 cosine 3 to x all over 15 and plus c.